Hey guys, and welcome to this new video in the Android application development series. In today's video, we will take a look at multi-threading. We'll mainly look at what it is and why we would use it in our Android applications. So first of all, what is multi-threading? Well, if you know a little bit about computers and about phones hardware, we know that they run with processors. And nowadays, processors are able to do something that's called multiprocessing. In order to use multiprocessing, we have to make sure that we give multiple threads of execution to the processors, which is multithreading. And in multithreading, we have a certain infrastructure, because multithreading, when we explain it in normal language, is as if you're reading multiple books at the same time, but you're switching between the books with every chapter that you finish. To do this, there is an infrastructure of a scheduler, a processor, and a dispatcher. The scheduler is responsible for managing the priorities of the different threads, or in this case, the different books on the shelf. The scheduler is responsible to make sure that every book is finished at the end, but the way how and which chapters to read when, that's something that the scheduler decides by itself. From here we go to the processor, and this is where the books or the threads are actually run. Finally, we also have the dispatcher, and the dispatcher will make sure that a thread is created and that it has the right context to execute. So then, why would we want to multi-thread in the first place? When we look at Android, there's a main thread, namely the UI thread. And this thread has to update the user interface every 16 milliseconds in order for the app to be responsive, or to have a smooth appearance. If it can't update the user interface every 16 milliseconds, we will either get a very laggy app, or if it's very slow, we will get a Android non-responding message like this one. And the reason why we could get those messages is because we do certain computations or executions on the UI thread that take longer than 16 milliseconds. This will cause the UI not to update within that time interval. And the way to thus avoid it is by making new threads that happen simultaneously or like parallel to the UI thread. But this allows the UI thread to update still. So the way we can do this multi-threading in Android is with three functions. First of all, we have the thread class that we can use. As I said, this is a class and thus the most raw form of creating a thread yourself. Secondly, there's also a framework that's called executor. In this case, we don't really create the new thread from scratch, but we use a thread from the existing thread pool that executor creates. In some cases, this could be handy to use instead of the thread. But one thing that we almost always need is a runnable. A runnable is where you define the actual execution that needs to happen. So when you either create a thread or an executor, you give it a runnable to say, okay, on the new thread, this is what needs to happen. So now you might wonder, okay, so then I have my runnable execution, it happens on a new thread, but what if this execution or computation needs to update something on the user interface? I can't do that in the second thread because it's not the UI thread. Well, in this case, we have to create some form of bridge between the two threads. And the way we can do that is either with a handler callback or the method that's called run on UI thread. Either way works, but when you start multi-threading, I really recommend you to read up on the documentation of the two and decide which one you want to use or which one you want to learn more about. So lastly, there's also alternatives to multi-threading, namely the use of services. If you remember from the first video in this series, we talked about the different components in Android, and services were one of them. And here we define that a service is a background task running without a user interface. So we can use this service or consider using it when the execution we want to do is very lengthy or very intensive. Secondly, we can consider it when we don't require a user interaction, which could be, for example, downloading content in regular intervals. You can imagine here that, for example, Instagram wants to refresh your feed every now and then, and this just happens on a timed interval. So this can be done by a service rather than a thread. There's also the option that you have a lengthy operation that shouldn't be stopped when you close your app. For example, the downloading of a certain video. In this case, you might want to use a service, because when you close the app, the activity and its threads will be closed, and the service will keep on running. And last but not least, if we want to share data with a different application, then services are also the perfect option. This was a very short introduction to multithreading. I know that we didn't really go into how do we do it and the practical side of it. If you want to see a video about that, leave that in the comments below. But I hope that this has raised some awareness about what multithreading is, how you might use it, and where you can find the resources to learn about it. And we will see each other in the next video.